In this video, we're going to learn what will be the value of gravitational acceleration when we are moving inside of the earth core. All right, so this is the idea, this is the question first, and we'll try to find the answer for this question. What will be the variation of the g? It will increase. Let's pause the screen and you answer by yourself. I believe you said that definitely the value of the g will increase because we are going towards the center, towards the core of the earth. Is that true? Let's find out. All right, so this is the surface of the earth, right? Now we are moving, we are digging a tunnel and we are going inside of the earth. Okay, so after digging a tunnel, after a couple of kilometers, when we got inside of the earth, we reached here. Okay, we reached here, we have made one tunnel over here and we reached here. So this is the tunnel, right? Now again, if you be a little bit realistic, then you will be able to understand that the gravitational acceleration will not decrease or increase. I don't know what we're going to find. It's not that much, there is not much that difference when you have moved a little bit from the surface of the earth. Now what you can do right now, you can move, let's say for example, up to this layer. Okay, you have made one tunnel, you have you come to here at this particular point, and now you can see there is a change in gravitational acceleration. Now what will be the change and how can we calculate that? Okay, so in the previous video, in the previous lecture, we have seen that g is basically proportional to gm by r square, where the g and m, they were constant. In the previous case I told you they are constant. Why they are constant? Because g is universal law of gravity. We know that this value is 6.67 into 10 to the minus 11 newton meter square per kg to the power minus 2. The value of the mass of the earth is constant, but if you look closely, this mass is not remaining constant in this case. Okay, in this case the mass is changing when you are at the surface of the earth. For example, you are at the surface of the earth, let's say you are walking, you are running, I don't know what you are doing. So when you are at the surface of the earth, you have all the masses of the earth. But when you come down here, okay, let's say for example, you are a mining person, you have come down here, and now as you can see, this person or you do not have the entire mass of the earth, which is basically responsible for your weight, or which is basically attracting you towards its core, right? So the mass has decreased. If this is the point where the earth center lies, so this radius we are naming that small r, right? So this radius is not equal, this radius is definitely not going to be equal to the surface of the earth. So radius is also decreasing. That means from this formula, if you can hold, the radius is decreasing and also the mass is changing. So we can say that when we are going deep inside of the earth's surface, then there are two quantities that are changing. One is proportional to the mass and another is the radius. Okay, so now you have to calculate this one. This one is a little bit confusing. That's why you have to calculate this one. We need to we need to consider one thing, and that consideration is that the density of the earth. We are considering that the density of the earth is constant throughout the entire volume of the earth. So we are taking the density is equal to rho, and which is basically constant. Okay, so in order to get this idea very clear, we will take the help of a deeper picture. Okay, so let's say this one. Okay, as you can see this diagram, so this diagram is depicting very carefully what is basically the change when we are getting inside of the earth core. For example, let's say we are here, one person is here, okay, and one person basically is standing here. Okay, so now you know that if this is the earth core, for example, if this is the earth core, then the radius for which the earth is attracting this person number 2 and this one is person number 1, the earth, which is basically the mass of the earth, which is basically attracting the second person. Let's say for example this one is the core is this, and this radius is small r. You can see that the inside sphere, and this person has one bigger radius, and which is basically capital R. Okay, so if we consider these two things, then we can easily get the idea of what we are going to do, right? So basically the mass of the earth, if we talk about the masses, so the mass of the earth is equal to, we know that the density is mass by volume, right? So the, we are talking about the mass, so the mass will be density into the volume. Now if we consider this one is a sphere, so the volume of the sphere will be 4 by 3 pi r cube into rho, and I have taken rho is equal at every space. So this one is the actual mass or the outer mass. We can name that number 1 m1. M1 is the total mass of the earth, and if we take the m2, if we take this surface, is this sphere is 2 and this sphere, the outer sphere, is 1, so this is m1, and m2 will be 4 by 3 pi small r cube into rho. Yeah, you can get the idea. So from these two equations, what I can do is write down the value of the gravitational acceleration. So let's say the gravitational acceleration on the surface of the earth is g, and over here the gravitational acceleration is g dash. Okay, so g is equal to, you can write capital G, and the m in space of m1 we should write here 4 by 3 pi r cube into rho, and by the capital R square. Okay, this is equation number 1. Now g dash, if we talk about the g dash, let's take a yellow color. G dash is equal to, capital G, then small m. In place of small m we are writing, or m2, in place of m2 we are writing 4 by 3 pi r cube, sorry I'm sorry, definitely that would be small r cube, yeah, into rho divided by small r square. This is equation number 2. Now if you look closely these two equations, then you'll be able to understand is that this r square and this r cube are getting cancelled, this r square are getting cancelled. So basically if we divide equation 2 with equation 1, we will likely to get d g dash by g is equal to definitely g and 4 by 3 pi r into rho divided by g 4 by 3 pi into r into rho. Now all the terms are they getting cancelled from each of the sides. So what we are getting from here is the value of, let's say all the terms are cancelled, rho cancelled, and this r by capital R. Now we know that, let's take this height is h, this height is h. We have gone h depth from the surface of the earth, and we have reached at some radius, and this radius is small r, right? So if this value is h, then we can easily get the idea that h is equal to what is the value of the h? You will say that r, capital R minus small r, right? So capital R minus small r, that is the idea. So if we say that this capital R minus small r, so small r is basically the value of the small r is equal to r minus h. So if you plug in this value over here, then this value is r minus h by r over here, and g dash is equal to 1 minus h by r into g. Okay, so this is the formula what you need to remember for the variation of g due to depth h from the surface of the earth. The variation of the gravitational acceleration when we are moving inside of the surface of the earth up to depth h. Alright, I think you have understood. So we'll move on to the next class.